Okay, nothing new. That's cool.
The game last night made me lose our little thing.
Oh, the bracket.
I was winning up until yesterday.
Well, that's something.
It's embarrassing for everyone else.
Because you don't know anything. All right, so at this point, you guys should have been able to do up to 64. Let's start with questions from the homework. So anything that you come across, Jack?
53.
Okay. So 53 asks you to find the product of these things. So we just need to multiply the r's. And we need to add the thetas. So far, so good. So the only thing we have to do here is add these fractions by making a common denominator. So the common denominator between 2/3 and 1/4 is 12. So I have 8/3 plus a -3, or 8/12 plus a -3/12. So that's positive 5/12. Oops. Cosine. So done. Yup. Zach, what'd you have? You had your hand up, right?
Number 60.
So this is just a division. So same idea. So we're just going to do the quotient of the z's. So 4/3 divided by 9 is the same thing as 4/3 times 1/9. So that's going to be 4/27. And then we're going to subtract. So -71 minus a -193 would be positive 122. So we're done. Is that cool? Okay. Aiden, did I see yours?
Could you just do how to find the R for number 21?
Sure.
What's the puzzle?
So for 21, R is going to be the square root of -5 squared plus 5√3 squared. So that's going to be 25 plus 75.
Okay, it's just like when I plugged in my calculator, it plugged in weird.
Yeah, so the thing you probably have to be careful about is the parentheses on stuff. Oops, there's no negative there. Oops. And then there it is.
Oh yeah.
So if you goof the parenthesis or whatever, cause you a problem. But that's what's going on. Grace. 30, which one? 39? Sure, so we're just converting this into standard form. So it says leave the answer exact if possible. So the first thing I'd want to do is check to see if 7 pi over 12 is a unit circle value. It's not, the other, you can tell that by looking at it, since the denominator is 12, or if you didn't remember, you know, you can just convert it to degrees, and 105 is definitely not a unit circle angle. So all this is a calculator problem. So I'm just going to set my calculator to radian mode and just kind of type things in. So I have 18 times cosine of 7 pi over 12. So that's my A value. And then do the same thing for sine. So that's my B value. So I have negative 4.66 plus 17.39 I. Oops. Is that okay? Yep. Zach?
Can you do number 1?
Plotting these things?
Yeah.
It's just like, this is your x, and that's your y. That's it. Is that good enough?
Yeah.
Okay. Lexi. 60, which one? 63. Sure. So we'll start by dividing these things. So again, we're just division of a fraction, the same thing as multiplying by a reciprocal. So 3 times 4 root 2 is going to be 12 root 2. And then I'd have cosine of negative pi over 3 minus a negative 5 pi over 3. So that gives us 4 pi over 3. And I think it asks for trigonometric form, so we're done at that point. Is that okay? So again, division, you divide the r's and subtract the thetas. Multiplication, you multiply the r's and you add the thetas. At least when you're trigonometric form, right? Anybody else? Zach?
Can you just do another one in that section? Like 62, I guess.
Okay. I mean, we've done 60 already. So again, I'm going to have 8 divided by negative 3. And then we just have to subtract these. So like 5 pi over 6 minus 3 pi over 4, making a common denominator. So the common, or the result is pi over 12, and I'm done. You know, Jack?
Is it? This is just a question. Is it possible to check your answers with these by like putting it in the calculator power pi and see the fraction?
Yeah, sure. Yeah, Sophia?
Can you do like
29. So going to the unit circle, cosine of 30 degrees is square root 3 over 2. Sine of 30 degrees is a half. And when I distribute things through, I get 2 root 3 plus 2i. Is that okay? Dom?
Can you do 47?
So I have 1 minus I over root 3 plus I. To divide, I'm going to multiply by the conjugate. So that's root 3 minus I. So just multiplying things out now. in the numerator, I get square root 3 minus I root 3 plus I squared. In the denominator, I get 3 plus 1. So remember, I squared is really just negative 1. So I have negative 1 plus 3, or root 3 over 4. That's like the A part. And then the parts with the I, I'm going to have negative 1 minus root 3 over 4. And then I'll just tack the I on at the end. So what I'm being careful here, I'm writing it in this strange way because I want A plus BI. Right? It's asking us to write it in standard form. So that's why it looks kind of goofy. It's like, what was wrong with the fraction before? It's the same thing. Well, it is, but it just not followed the directions so much. You know what I mean? You just want to break up the real parts and imaginary parts so you have that A plus BI.
So if it asks for it in standard form, you always want to like pick up the I.
It should look like A plus BI, you know, like, and I wouldn't complain if you did like, if you put the I over here or something, but should just have one I in there somewhere, so it should be factored off. Grace. Yeah, you just type it in your calculator just like you would have done 39. You just have to change it to degree mode. Again, the point is that you're looking, 68 is not a unit circle value. So there's no exact answer, so you're just going to type it into your calculator. So you do 12 cosine 68, that's your A, and then 12 sine 68, that's your B, and then just stick the I on at the end. You know what I mean? Does that feel okay?
Yeah, I was just like, I just was confused for a second.
Yeah, I mean,
Like where if you like multiply it.
you're just getting an A plus BI, so the A is the part without the I on it, the B is the part with the I on it. You know what I mean?
Yeah, okay. Thank you.
Sure, Jack.
How did you do that check to see if it was on to you? Was it the...
Oh, I just converted it 7 pi over 12 into degrees, because I knew the angles on the unit circle in degrees, for sure,
Okay.
right? Because they're all multiples of either 30, 60, or 45, and 105 isn't a multiple of any of those things, so...
Okay.
I mean, I could have done it with like an angle sum formula, I guess, if I wanted to be like really sneaky, because 105 is 60 plus 45, but like that's like, it's a lot of extra just to get an exact answer out of it, which I don't think is really reasonable to go pull that hard, you know. Okay, cool, let's finish up chapter 11 then. So this is the last section in chapter 11. So here we're talking about powers and roots of complex numbers. So let's talk about powers first. Let's just say that we have some complex number z in trigonometric form. If I want to do z squared, remember z squared is just z times z. So if I apply my multiplication rule, I would multiply the r's together and then add the thetas. To get that, right? No big deal. If I try z cubed, well, I can think about that as really z times z squared, right? Well, the r on z is just r, and the r on z squared is r squared, so r times r squared is r to the third. And then we need to add the thetas. So I have theta in z and 2 theta in z squared. So that gives me 3 theta. And at this point, hopefully, a pattern is beginning to emerge for you. So if I have z to the n, what's that going to equal? R to the n times n theta plus I sine n theta. So that's our formula. This formula actually has a name. This is called Demovrey's theorem, named for a French mathematician who discovered this. So let's say we have 5 cosine 14 plus I sine 14, all to the 5th power. What do we do there? Jack? 5 to the 5th times cosine of 5 times 14 plus I sine 5 times 14. So 5 to the 5th, I think, is 1325. Somebody with their calculator out can check that for me. 3125, thank you. And then 70. So that's our trigonometric form, or if you were so inclined, depending on the direction, if they wanted standard form out of this, just make sure your calculator's in degree mode. 3125 times cosine 70, and then same thing, sine 70, so I have 1068.81 plus 2936.54 I. So depending on the direction, whether they wanted trigonometric form or standard form, your answer would be one of those two. Easy, right? Righteous. That's pretty great. Does it get more complicated than that? Not for powers. All right. This is nice. Trigonometric form, rock and roll, right? Pain in the butt to get it, but once you got it, like all the operations, super easy. What would you have to do if you had like a standard form power? Convert it to trigonometric form and then use the formula, right? It's way better than trying to like FOIL out 5 of those A plus BIs, like, you know, talk about tedious. Not that you couldn't do it, but like, woof, that takes way too much effort. Particularly if the power is like 25 or something. Like, yuccaroni, trigonometric form, it's done almost instantly. All right, let's talk about roots then. So again, let's say we have some complex number z that's in trigonometric form. And we want to do, say, the nth root of z. Well, if you remember back from your Algebra 2 days, you'd remember that the nth root is the same as the power 1 over n. And you're like, oh, great, Demovrey's theorem. And I'll just be done, right? Oops. Right? Not quite. Not quite. What are we missing? We need to account for coterminal angles. So what this really becomes or if you prefer to work in radians, instead of 360, we would write 2 pi. Loop. So if we look at the possible values of k, what do you notice? How many values of k do we have? Not infinite, because it ends. We have n values, right? If I count from 0 to n minus 1, that's n numbers. So you're counting 0 to 4, there's 5 numbers there, right? Everybody's cool? So there's going to be n answers to this. So if it's a cube root, we're going to have 3 answers. If you have a 10th root, you're going to have 10 answers. Everybody's cool? All right, let's look at a specific example then. So let's say we want the cube root of 3 minus 2i. What's the first thing I would do here? Yeah, I'm taking that 3 minus 2i and putting it into trigonometric form, because that's where all of the good formulas live. So if I plot that, we're down there. So theta is going to equal 360 minus tan inverse of the absolute value, negative 2 over 3. Go to my calculator. And I chose to just use degrees rather than radians here. It doesn't really matter. But since my calculator was already in degrees from the previous problem, I just used degrees here. And notice I'm doing the absolute value part in my head. I didn't bother to type that into my calculator. So I got 326.31. So 3 minus 2i is the same thing as the square root of 13 times cosine 326.31 plus I sine 326.31. So far, so good? Okay, so that was step 1. To do the cube root now of this, we're going to have the cube root of r, then the cosine of 326.31 plus 360k over 3 plus I sine 326.31 plus 360k over 3. And our k is going to be equal to 1, 2, or 0, 1, and 2. So far, so good. All right. So if we grind this through, the cube root of the square root of 13 is really the 6th root of 13. Wait a minute, Mr. Kulik. What did you just do? Remember that radicals are the same thing as exponents. So a square root is a 1/2 power. A cube root is a 1/3 power. And if you do an exponent of an exponent, you multiply. 1/2 times 1/3 is 1/6. Back to a radical is a 6th root, right? Algebra 2, exponent rules, last year. Okay. All right, so if k equals 0, I'm just going to have cosine 326.3 over 3, and then I sine 326.31 over 3. So that's when k equals 0. If k equals 1, I'm going to have 326.31 plus 360, or 686.31 over 3. And then if k equals 2, I'm going to have 326.31 plus 720. So that's going to be 1046.31 over 3. So I sine 1046.31 over 3. So those are my answers in trigonometric form. If I wanted them in standard form, what would I have to do? Just type that stuff back into my calculator, right? As a little reminder to type in a 6th root, I'm just going to press a 6. And if I press the math button and choose this option 5, that's the xth root. It'll make a 6th root for me. Alternatively, you could have typed 13 to the 1/6 power. That's okay too. So like you could have also done 13 to the 1/6. That's the same thing, right? So, for example, this one would have been 1.5 minus 0.30i. If you wanted the standard form. I'm not going to do it for all of them just because it's like kind of an incredible hassle. I just don't want to do it. Is everybody okay with that? Lexi?
Why did we identify that k was 0, 1, 2?
Because k is 0 to n minus 1. And n is the index. Right? N is the index of our radical. So n is 3 in this case. Is that cool? Now let's just say hypothetically we're like, Mr. Kulik, I forget the k rule, and I'm just going to keep doing this. What would happen if I had done k equals 3? Well, if I do k equals 3, 3 times 360 is 1080. And 1080 plus this is 1406.3, which is actually coterminal to this one. So if you did more than 3 Ks, you'd just get coterminal things. What would happen if you started with 1 instead of 0? You'd get the same 3 values, you just get like coterminal values potentially, and they'd be in a different order than mine, but they're the same 3 answers in standard form, and you get the same 3, or the same answers in standard form, and you get the same equivalent answers in trigonometric form. So really the values for K, all you need is like n consecutive numbers. It doesn't even matter what the numbers are, you know? So, but like, save yourself the hassle. Go start with 0, you know? It's much easier that way. All right, let's do one more, and we'll call it a day. Sound good? All right. Say we want to find the 4th root of 16. What's that? Well, 2 is incomplete. How many answers are there going to be? There's going to be 4. Well, let's see where we're getting the 4 from. So R, let's just do it the easy way. So 16 is like here, right? So R is 16 and theta is 0. Cool with that? So if I want the 4th root of 16, I'm going to have the 4th root of R times cosine of 0 plus 360k over 4 plus I sine 0 plus 360k over 4. So we have an answer for k equals 1, 0, 1, 2, and 3, right? Okay. So for k equals 0, well, the 4th root of 16 is just 2. Cosine of 0 is, well, let's just write it this way, I guess. Cosine of 0 is 1. Sine of 0 is 0. So that just becomes 2. That was the answer Aiden gave. When k equals 1, I'm going to have 360 divided by 4, or 90 degrees. Cosine of 90 degrees is 0. Sine of 90 degrees is 1. So it'll give me 2i. When k equals 2, I'm going to have 720 divided by 4. That's 180 degrees. Cosine of 180 is negative 1. Sine of 180 is 0, so that's going to give me negative 2. And when k equals 3, that's 1080 divided by 4, so that's 270. Cosine of 270 is 0. Sine of 270 is negative 1, so that'd be negative 2i. So again, standard form answers, trigonometric form answers, depending on what your directions were asking for. Either is appropriate. And again, if you had gone to k equals 2, you would have just gotten cosine 360, sine 360, which is coterminal to cosine 0, sine 0. So you knew you were done at that point anyways. Not too bad, right? This is the hardest thing really in this chapter, basically, right? And this isn't even really that bad because it's just like grinding through a formula. All right. You want to hear the bad part, though? Yeah, if you've already done to 64, you're thankful at that point you've done to 64, right? Yeah, I know.
What are you asking in these questions? That there's 55 of them.
You know, you got to just, yeah, like
55 questions from this chapter?
you got to do it in like, leave your answer in standard form, leave your answer in trigonometric form, and do it this way, do it that way. Like, you know, just,
That's so extra.
yeah, it kind of is, but
Right before spring break, too.
you still got you got a whole next week before spring break. Don't get out of
Next
here.
week, let's be real. Next week is not a real week.